Yeah, perfect. Okay. So let's begin with the session, guys. Today would be the last session with respect to collections here. Okay, so today I shall try to complete the remaining things with respect to collection here. Okay. So now here in today's session here we are going to talk about a very important topic. Okay, that is nothing but map. Okay, what is a map here? In simple terms like set queue list here, map is also an interface. Okay, map is a predefined interface in java.util package. What is it? It's a predefined interface present in java.util package, and it was introduced from JDK 1.2. It was introduced when? It was introduced from JDK 1.2 here. Okay, so this interface is a part of collection framework, but does not extend collection interface. Okay, always remember this part here. Map is a part of collection framework. Okay, but it does not extend the collection interface. Okay, and whenever we talk about map, right, the speciality about map is to store, okay, key and value pair. Whenever we talk about map, it is always used to store key and value pair. And one key and one value together, we call it as entry. So map means it is used to store the objects in terms of key and value. So one key and value together, we call it as an entry. So I can tell map is a collection of entries. One key value pair is called as entry. So if I have multiple key value pairs, it's entries. Okay. So map is a collection of entries. And whenever we talk about map, it has majorly, okay, four implementation classes. Okay. What are those? Hash map, linked hash map, and tree map here. It's something similar to set only. Hash set, linked hash set, tree set. Similarly, hash map, linked hash map, tree map, and we also have something called as hash table. So these are the four implementation classes of the map interface. Okay, so we just need to understand the hierarchy of map here. So let us try to talk about the map hierarchy over here. Okay, so now in this specific process here, let me try to create an interface. That interface name is map. Okay, under that we have sub interfaces. That is, one is called as sorted map. Okay, then comes navigable map. Okay, and the remaining things are classes. Then we come across something called as tree map here, which is a class, and we have something called as hash map here, which is also a class here. Okay, I'll tell it as hash table. Okay, and we also have something called as hash map, and then linked hash map. Okay, so this is with respect to the process here. So let me just try to draw this representation so that it becomes very easy to understand. Okay, so these are the different process over here. Okay, okay, so these are the different classes and interfaces. So now map is the supermost interface, guys. Under that we have hash map, okay, which is implementing. Hash map means it's a class. Okay, hash map is a class here. So if it is a class, it has to implement. And class to class, it is nothing but extends. So linked hash map is a class that extends another class called as hash map, and hash map implements an interface called as map here. Okay, and sorted map is an interface, easy relationship is extends, and over here it is dotted arrow mark. Okay, and over here it's a class. So class means it is implements. So these are the few things which we are supposed to understand when we talk about map here. So map is the supermost interface, guys. Under that, four classes: hash map, linked hash map, tree map, and hash table. So these are the four implementation classes of the map interface. But we have this particular hierarchy which you are supposed to be, you are supposed to understand. Okay, so this is all about the entire process here. Okay, so when I go back to the notes over here, okay, just observe what is happening here. Okay, what is map here? Map is a part of collection framework which does not extend the collection interface. Meaning, map is present in collection framework, okay, but that will not inherit the collection interface. When we talk about list, queue, and set, they were a part of collection framework and they used to inherit the collection interface. But map does not, it does not inherit the collection interface. Okay, and how is the data or objects organized inside a map? Wherein the objects inside a map are generally stored in the form of key and value pair. Okay, keys cannot be duplicated, but values can be duplicated. Like if you go to a company, employee IDs are always unique, but the names can be duplicated. Okay, multiple employees can have the same name, but they cannot have the same ID. Therefore, keys cannot be duplicated, but values can be duplicated. So what is map? It's a predefined interface in java.util package and introduced from JDK 1.2. Okay, and what are the implementation classes of map here? Hash map, linked hash map, tree map, and hash table. So one key and value pair we call it as entry. So map is a collection of entries. Done. So this is what we are supposed to understand when we talk about map. Okay. Now when we talk about map, we have certain important methods here. Okay, so what are those methods, sir? We are supposed to understand those methods. That is put method, get method, clear, is empty, remove, contains key, contains value, and key set. Sir, what is the working of those methods, sir? I will tell you in a beautiful way here. But now, can we achieve upcasting over here, guys? Can we achieve upcasting? See, I will have a reference as map m here, but I can store the object of hash map over here. Okay, I can store the object of a linked hash map over here. I can store the object of tree map over here. I can also store the object of hash table over here. Why? Because what is upcasting? Creating an object of subclasses and storing its address into reference which is of type superclass, and the type is super interface, that is M here. So we can achieve this successfully. Why? Because upcasting. Okay, so that's how we are supposed to understand over here. Okay, so this is all about maps, guys. Okay, but the only thing we have to understand is the practical part. So for everyone who came late, map means it's an interface present in java.util package and introduced from JDK 1.2. How is the objects are organized there? Key and value. Keys cannot be duplicated, values can be duplicated. And one key, one value together we call it as entry. So map is a collection of entries. And how many implementation classes do we have in map? 4. Hash map, linked hash map, tree map, and hash table. So map does not inherit the collection interface. Okay, keep in mind. Okay, and what are the important methods here? We have put, get, clear, is empty, remove, contains key, contains value, blah 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 blah. We'll try to understand. So now let us try to talk about something called as hash map. Hash map means it's a predefined class in java.util package and it was introduced from JDK 1.2. And what is the specification of hash map here? Insertion order is not maintained. It's similar to hash set, guys. Hash set does not maintain insertion order. Similarly, hash map also does not maintain insertion order. And the underlying data structure is hash table. Hash table means the objects are stored in key and value pair. Okay, so now we are just supposed to talk about the working of it. Okay, so we did 7 days of collection here, and today will be my last day with respect to collections here. So I'll write it as map programs. Okay, map programs will be the last topic with respect to collections. Under that, I will create a class, and the class name is demo here. Okay, demo is the class name, and I will also have my main method wherein the execution will always begin from. Okay, main method is wherein the execution will always begin from. So now here I will create an object of hash map. Hash map h equals to new hash map of. I create an object of hash map. But why the hell is it giving an error? Sir, it is present in java.util package, sir. So therefore we have to import it, sir. Very good. So hash map, as I told you, everything, whatever classes and interfaces we are using in collection, it is present in util package. So we are supposed to import it. So I will import it. Now, if I want to add an object into hash map, okay, if I want to add an object into hash map, if I make use of add method, it's giving an error. Why? Because add method is present in collection interface. I repeat, add method is present in collection interface. From collection, it was inherited to list, queue, set. And from list to queue set, it was inherited to array list, linked list, hash set, linked hash set, tree set. But now, since map does not inherit the collection interface, we cannot use the add method. Rather, if I want to add an object into the map here, I have to make use of a method called as put method. Okay, so the job of the put method is nothing but we are going to add a key and a value. So I'll tell the key is 10 and the value is dinga. Okay, so put method is used to add key and value pair within the hash map here. Okay, again h dot put of, I will tell the key as guldu. Okay, I'll just tell the key as guldu here and the value is 10.45. And h dot put of, I will tell the value as 1.2 and the value is 100. So here put method is used to add, okay, put method is used to add key and value inside map here. Okay, put method is used to add or insert key and value inside map here. Okay, it is used to add an object, key and value pair within the map here. Okay, and when I try to print the object reference here, since the toString method is overridden internally, when I execute it, I should get the output here. See, insertion order is not maintained at all. I am inserting in one order and I am getting the output in one respective order here. So hash map will never ever maintain the insertion order here. Clear? So the job of the put method is used to add an object into the collection here. The collection which I'm using right now is map here. Okay. Similarly, I have so many important methods which I have to talk about. So the next method is h dot get off. Okay, get off 10 here. So means the job of get method is used to get the value based on the key specified. Okay, get method is used to, okay, is used to get an object, okay, get an or value based on the value based on the key specified. Okay, so when I tell get of 10, the key is 10. What is the respective value? Dinga. So I should get the output as dinga here. Did I get the output as dinga here? Yes. Now when I tell system.out.println h.get of, I give it as 230. So I'm telling get of 230. So I'm getting the value, okay, where the key is 230. Do we have any key by the name 230? No. So I will get it as null here. So null means there is no object, no value with the key 230. So 230, there is no key called as 230. But what is the value? Null means nothing. Okay. Similarly, I will have h dot contains key of, I will write it as guldu. Okay, do we have any key by the name called as guldu here? But now it will give me false. Why? Because Java is case sensitive. It is case sensitive in the sense here, okay, uppercase guldu is not available. Okay, uppercase guldu is not available. So it returns false. But lowercase guldu is available. So therefore it returns true here. So what is the job of contains key method? Okay, contains key method is used to, okay, check if the key is present or not. Okay, if the key is present or not here. If we have contains key, we should have a method for contains value as well. Okay, contains value, and do we have the value called as 10.4.5? Yes. So now if I tell it as a dinga over here, h dot contains, oh just a moment, h dot contains value of, if I give it as dinga here, it will give an error. Why? Because it is uppercase dinga here. Okay, contains value. So now when I execute it, first it will be true and then it will be false. Why? Because 10.45 is there. The value 10.45 is there, but dinga is not there because it's lowercase dinga. So it gives me false here. So the job of contains key is used to check if the key is present or not. Contains value is used to check if the value is present or not here. So that's the job of, okay, 4 important methods. Okay. Put method is used to add key and value pair. Get method is used to get the value based on the key. Contains key, contains value, checks, oh, if that key is present or not, if that value is present or not. Okay. Similarly, I have, see, sys out, I will print h, meaning I'm printing the map values here. And then I will tell h dot remove of, I specify the key called as 10. Now when I try to print h over here, look at the output what I get here, sys out h. So when I execute it, look at the beautiful output what I get here. When I execute it, my map was containing 1.2, 10, Guldu. Okay, it was containing some object. When I tell remove of 10, it is used to remove an object based on the key here. It is going to remove that respective value, okay, based on the key here. I have told remove of 10. So therefore, remove of 10 means that respective object only gets deleted here. So the job of remove method is to remove a value based on the key specified. So what is the job of remove? Remove is used to remove a value. Okay, remove a value based on the key specified. Okay, so that's the job of remove method. And then the last part which we are supposed to understand is this, everyone knows, h dot is empty, and I tell h dot clear, and then finally I will tell h dot is empty. So now when I just execute the complete program here, you will get a complete clarity about what is happening over here. So when I check here, initially it gives me false. Is it empty? No, my map is having some data, so it is not empty. But when I tell clear, all the objects are removed from the map here. Okay, everything is removed from the map. So once I tell is empty, so it gives me true here. So the job of is empty method, okay, is empty method is used to check if the collection, okay, is empty or not here. Okay, and clear method means clear method is used to, okay, is used to remove all the objects from the collection. Okay, from the collection it's going to remove everything. Okay, not even a single object is retained. Okay, so that's all about all these 7 methods here. But what is the job of key set method, sir? I will talk about it. So this is what we are supposed to understand. See, the 7 method specifications we have seen. Okay, put method is used to add key and value. Get method will get the key, get the value based on the key. Clear will remove everything. Is empty checks if it is empty or not. Remove will remove a value based on the key. Contains key checks if that key is there or not. Contains value, check if that value is there or not. What is the job of key set? Now I will do it in the next example. So that's what we are supposed to understand here. Okay. So I hope you got the clarity about hash map here. Okay. And now when we talk about linked hash map, just see the major difference, guys. Okay. Hash map, it's a predefined class in util package. It's also a predefined class in util package. This was introduced from 1.2. This was introduced from 1.4. But the problem in hash map is insertion order is not maintained. But linked hash map is insertion order is maintained. It's similar to hash set and linked hash set. Insertion order one maintains, one does not maintain. and the underlying data structure is linked list and hash table. Hash table means key and value pair, and linked list means insertion order is maintained. So that's what we are supposed to understand. So now when I just create an example called as test, and if I have my main method over here, okay, so now I will tell, see, linked hash set, okay, linked hash map, sorry, not set here, linked hash map LHS equals to new LHM, okay, linked hash map, okay, new, I will just copy this entire process here, okay. If I create an object of linked hash map, I have to import it because it's in util package. Now here, as of now, if I do not use generics here, I can store heterogeneous objects. See, keys can be integer, string, double, values can be integer, double, string, anything. Because as of now, by default, collection is heterogeneous. But if I want to tell linked hash map, please allow the keys to be int and the values to be string. So what will I do here? I specify generics and I tell the keys has to be int here. But int is not primitive. Okay, int is primitive. So collection will allow only non-primitive. So the respective part is integer will be the key, comma, and the value will be the string here. So I'm specifying two parameters over here. So integer is the key and string is the value. So you can specify the constructor side also. Optional, okay, not mandatorily. Optionally, we can specify it at the constructor side. Okay, right after the class name, you have to specify this generics here. But most common mistake you do is, as soon as you write this, you'll remove this parenthesis. If you forget this parenthesis, again it's an error. Okay, so be very, very specific in what you're trying to do here. Okay, so you have to write parenthesis over here. Now I will tell, okay, LHM dot put of key should be always integer and the value should always be string. See, it's telling now because we have used generics and told, okay, key, it should be int, value should be string. I'll tell the key as 10 and the value as, I will write it as Java. Okay. Similarly, I will copy paste it thrice. Okay, I will copy paste it thrice. 10, 20, 30, and here I'll write it as SQL, and here I'll just write it as, okay, web over here. I'll write it as web over here. Okay, so Java, SQL, web. Okay, web technologies. Okay, now here internally, what will happen? Internally, okay, internally, an hash table will get created. Okay, I'll just tell you here. Just observe internally what is happening over here. Internally, an hash table will get created, and the hash table will always store the objects in terms of key and value pair. Okay, it will always store the data in terms of key and value pair. This is the key, this is the value. Key is of type integer and the value is of type string. Okay, key is of type int and value is of type string. Okay, so key is 10, 20, 30, respective value is Java, SQL, okay, SQL, 1 minute, SQL and web here. So this is what got created. But now if I directly want to traverse it, with the help of for loop, I cannot do it. Directly I cannot traverse it with the help of for loop here. Why? Because it's key and value pair, right? So I directly cannot use it with the help of key and value pair. So therefore, this is nothing but the map, LHM. That's the map, linked hash map. So now I will convert the map into a key set. LHM dot, I invoke a method called as key set. Okay, so the name is telling LHM is nothing but linked hash map. A map is getting converted into a set of keys. When I tell map.keyset, it means the map is getting converted into a set of keys. So therefore, a set will get created. Internally, what will happen? A set will get created. And the set is storing only the keys here. Okay. LHM means it's a map. Map.keyset means the map got created, got converted into a set of keys. And I give the name called as S. I give the name for the set is S. And what is the return type? It is set. Because it's a set of keys, no? So it's a set that is storing integer values. So here I'll write the generics type as integer. Okay, I'll just write the generic type as integer. Sir, what that happened over here, sir? I will tell you. See here, LHM is a map. Do you all agree? Linked hash map is a map. LHM is a map. Dot, I have a method called as key set. See, it's telling returns a set view of keys, meaning it's returning a set of keys. Okay, key set. Okay, I invoke this. Now, what is its return type? See, if I tell S here, after the map got converted into a set of keys, I am giving the name as S. But what is the type of S? It's a set storing integer values. So I'm importing the set also from util package. So once the map has got converted into a set of keys, can I make use of for loop over here and traverse the set here? 101% I can traverse it. Okay. Now here 10, 20, 30. It's an int value, correct? I will write it as int because I'm trying to traverse int values. It's int. Then can I give it as key here? It's a variable, no key. 10, 20, 30 is nothing but the keys here. I'll write it as key. Colon. From which collection? Yes. It's a set now from yes. So when I tell SOP and if I just try to print key here, I will get the output as 10, 20, 30, one by one, one by one, one by one, it will get stored here. 10, 20, 30 will get printed. See, I will have one for each loop for, okay. So here I will tell this set, you want to fetch the objects from set. It is having int values. The set is containing only int, no. It's key, colon. From which set? Collection is S here. So I tell sys out. And if I just try to print the key here, look at the output what I get here. I just get only the keys here. When I execute it, see here, I'll get it as only 10, 20, 30 here. I just got it as what? 10, 20, 30. But if I want the value also, sir, how will I do it? If I want the value, I will just tell. Okay, if you want the value here, I'll tell LHM is the map dot get off. I will pass the key over here. So when I execute the program over here, okay, when I just execute the program, observe what is happening. When I execute, can you see the respective key and value pair is printed here? Okay, so that's how you are supposed to understand. So now see here, guys. So what is happening, I've been telling LHM dot get of key also. So initially what happened? LHM is a map that is getting converted into a set of keys. Okay, set got created and that set is storing keys. 10, 20, 30 got stored. And what is this? This is a set storing int value. So it is set of integer. Now I want to fetch this 10, 20, 30 one by one. So int is the type of data and 10, 20, 30 are nothing but keys. So I'll just write it as key. From which set I need to traverse it? It is S. So first 10, right? So this S will go, 10 will get stored into key. The key is 10. Get of 10. What is get of 10? Java. 10 Java will get printed. Control goes back. Next 20 will get stored into key. So the key is 20. Get of 20. Get of 20 means SQL. SQL will get printed. Again goes back. 30 will get stored into key now. Okay. What is key now? 30. Get of 30. What is get of 30? Web. 30 web will get printed. So that's how we are supposed to traverse it with the help of, the data here. Similarly, I can make use of hash map also. Okay, I can make use of hash map also and try to traverse it. How, sir? See, hash map. Okay, h equals to new hash map of. Okay, hash map h equals to new hash map of. But I have to import it from which package? Java.util package. Now I want the generic type. Generic type is key is a string, okay, and the value is an integer, okay. Key is the string and the value is the integer. But optionally you can use it at the constructor side as well. So now I'll tell hm dot, okay, I'll take the map name as hm dot put method, put of key is string. So I will write it as Tom, okay, and the value is its age 22, okay. hm dot put, I will write it as key as Jerry and the value is 21. Okay, that's it. So now internally what happened over here? Okay, internally, okay, see what happened over here. Okay, Wait, I'll show it to you. I will prove it to you. So internally, one hash table got created. Okay, that is nothing but key and value pair. Okay, so what is the respective key and value? We have to decide here. So what is the respective key and value? We have to just decide and understand. So the key is, okay, key and value. Key is of type string and the value is of type integer. Okay, so the key is Tom and Jerry. And what is the respective value? 22 and 21. So now this is the map M, okay, HM. That is the map HM. So I want to convert it into a set of keys. HM dot key set. When I tell HM dot key set here, a set got created. And that see HM is map. Map key set. Map dot key set means a set will get created of a set of keys. I mean a set will get created with the keys here. So what are the keys? It's Tom. Tom will get stored and Jerry will get stored here. So map got converted into a set of keys. So what is this? S. It's a set. But what is this set storing now? It is a string here. Why? Because the keys are string. No, it's telling key set. It is creating a set of keys. It's a key set. It is creating a set of keys. So it's a set and the type of keys is string. So it is string here. So now I want to fetch it. For what is the type of objects I'm going to fetch here? It's string. If I want to fetch Tom and Jerry, it's a string. I will write it as string. And now this is a key. Tom is a key, Jerry is a key. It's key. Colon. From which collection? S. So I will tell SOP. I will print the key plus I will print HM dot get of key. So what is happening over here? See first what happens? S is nothing but Tom and Jerry. So key will be Tom here. Tom will get printed. Get of Tom. HM dot get of Tom is 22. 22 will get printed. Control will go back. Now Jerry will get stored. Key is Jerry. Key is Jerry here. Get of Jerry. What is get of Jerry? 21. 21 will get printed. That's how you cannot directly traverse the map here. So you convert it into a set of keys and then traverse it. So now I'll tell hm dot key set, meaning we created a set of keys here. So I'll just write it as S1 here because S we have already taken S1. And what is the type of S1 here? The type of S1 is it's a set of string values and the name of that container is S1. So for loop, and what type of objects am I going to traverse? String key colon. From which collection? S. So I can tell key. When I just tell key, I will get only the keys here. See Tom, Jerry. So I can tell here Tom is hm dot get of key plus years old. So now when I execute it, look at the output what I get. See, Tom is 22 years old. Jerry is 21 years old. That way we are able to print the content here. That's how we are supposed to visualize it and get the expected output here. So once we get along with it, it becomes a very easy process to understand. Clear? So this is all about the entire process here. But similarly, I will do a tree set also. Okay, I will do tree map here. Okay. So now what is tree map, sir? You will only understand in some time. Okay, just observe. Tree map. Okay. T equals to new tree map of. Okay, tree map of. Okay, done. So now here, if I just import the tree map. Now my collection here, my generics type will be, I should have int as the key. Okay, int as the key here and the value should be double. Okay, and the value should be double here. So, but it's giving an error. Why? Because it's primitive. So integer is the key and the value is double here. You can specify at the constructor side also. So you will tell t dot put of 20 comma 1.5. Okay, t dot put of 30 on put of 30 comma 2.5. T dot put of 10 comma 4.5. That's it. So now I want to traverse it. But directly I cannot do it. How will I convert it into a set of keys? T is the map dot key set. I am converting the map into a set of keys. After that, I give some name also. The name of the set is S2. Okay, the name of the set is S2. And what is the set containing? It's a set of integer values. Why? Because it's creating a set of keys. No. So set is containing int values. Set is containing int values. So therefore, I will traverse it with the help of for loop. So key, okay, it's string, sorry, int is a type of data, key is the variable, colon, from which set it's S2. Therefore, when I try to print the key and the respective value, okay, t dot get of key here. So I will get the respective key and value pair. See, I'll get the respective key and value pair. But what did we understand over here? Okay, hash set does not maintain insertion order. Linked hash set maintains insertion order, and tree set is sorted order. That is the natural sorting order. If you want, you can add one more object over here. hm dot put of, okay, hm dot put of, I'll write it as beam here. Okay, I'll just write it as beam and the value is 23. So that way, if you could closely observe here see the insertion order is not maintained, insertion order is maintained, and this is sorted order. So hash map does not maintain insertion order, linked hash map maintains insertion order, and tree map is always sorted order here. So that's how we are supposed to understand. So when I just look at the specifications of map over here, this is what we get to know it. See, all the classes, okay, hash map, linked hash map, and tree map are all predefined classes, and the implementation classes of the map interface are present in java.util package. Hashmap 1.2, linked hashmap 1.4, and tree map 1.2. So what are the specifications major? One does not maintain insertion order, one maintains insertion order, one sorted order. A data structure is binary tree here. Why? Because it's sorting. So that's all about, how you are supposed to understand the map interfaces and how do we work around with map here. Clear? This is all about maps, guys. Okay, it's not that you can have only string type of data here. You can have any type of data. See here, I will have a class called as fruits here. I'll have a class called as fruits only. Okay, and I will have a method called as main method. I will create tree set. Okay, tree set. Okay, I'm importing it. The key string, and the value is integer. It's t equals to new tree set of. Okay, so you can just ignore this part. Okay, so now over here, I will just say, oh, I'm so sorry, I'll create tree map then. Okay, tree map. I'm just used to this tree set, that's the reason I just made it as tree set. So let me just import the tree map over here. Okay, great. So we have imported the tree map here. T dot, okay, we can just add it as put. I can add the fruits. Apple, okay, and the value is 20. Okay, T dot put of, okay, I can write it as mango. Okay, mango here, and the value is 23. Okay, T dot put of, I'll write it as banana here. Okay, and the value is 45. Okay, so or else we'll write it as 15. Doesn't matter. Okay, done. So I want to traverse it. I directly cannot traverse it over here. So how will I traverse it? T dot key set. I am converting the map into a set of keys, and I'm giving some name. Okay, for name for the set here. So what is it? It's a set of string. Why? Because it's creating a set of keys, guys. So what is the type of keys? It is string. So the type will become string, and the date, the container is set. For each loop, okay. So I am going to traverse string objects. It's the key column from the set S here. Okay. So I can just write it as cost of, okay, cost of 1 kg. Okay, cost of 1 kg key apple is, okay, t dot get of, I can pass the key here. So when I just execute it, see it's in ascending order here. Cost of 1 kg apple is 20, banana is 15, mango is 23. Hey, the sorting is happening based on the keys, guys, not on the values here. See, apple, banana, mango. Okay, that way. Okay, it's not sorting based on the values. Sorting will always happen based on the keys here. Okay, so therefore, This is how we are supposed to convert the map into a key set of keys and try to traverse them. Okay, so this is all about the entire process with respect to map here. Okay, and there's one last part which we need to discuss. That is nothing but, sir, then what is hash table, sir? It's very simple, guys. It's something similar to array list and vector. Okay, I told you, no, hash map was, it's not thread safe, it is not synchronized, meaning it is multi-threaded. Hash table is thread safe, it is synchronized, okay, it is single threaded. So hash table is old, okay, 1.0. So it was thread safe. Synchronized meaning only one object can access the thread. So that's the reason hash map got created over here, which is not thread safe here. What is synchronized, what is not synchronized, you will understand when I do thread class here. Okay, but as of now, this is the major difference between hash map, hash table, and the remaining parts here. Clear? This is all about it, guys. This is all about the maps here. If I go back here, we'll just revise it. Just read out each and every points, guys. So what is a map? Sir, map is a part of collection here, but it does not extend the collection interface. The objects are organized in terms of key and value pair, wherein keys cannot be duplicated, but the values can be duplicated. Okay. When was it introduced from? It was introduced from JDK 1.2. It's present in java.util package. It's an interface. We have four implementation classes: hash map, linked hash map, tree map, and hash table. One key and value together, we call it as entry. So map is a collection of entries here. And what are the important methods? We have 8 methods, and we have seen all the working of 8 methods. And the major difference between hash map, linked hash map, and tree map is, as I told you, one maintains insertion order, one does not maintain the insertion order, one is sorted order. So I've given you the complete data. Hash map, no insertion order; linked hash map, insertion order; tree map, sorted order. And difference between hash map and hash table is, one is thread safe, one is not thread safe. What is thread safe? Later you will understand. So we saw all the working of all the 7 methods in the first program. Then we saw what is key set and how do we traverse it with the help of for each loop. So we have seen multiple examples for key set over here. And we also saw the last example for with respect to fruits here. Okay. So this is all about the entire process here. Okay. So we have a question. Sir, what if I have duplicate key, sir? Very, very good question. Okay. So now here, very good question. Okay. So here, I'll have a class called as runner, and I will have my main method. Okay. I will have my main method. Okay. Uh, just a moment. See here. I will create hash map. Okay. H equals to new hash map here. Okay. Now I create an object of hash map. H dot put off. I'll write it as 1. Okay. And here I'll write it as Sony. Okay. I'll write it as Sony, and H dot put off. H dot put off. I'll write it as 2, and I will write it as Apple here. Sony and Apple. So when I try to print this H over here, okay, look at the output what I get over here. I get it as 1 Sony, 2 Apple. But now here, if I tell H dot put off, same key, but the value is different. I will write it to Nokia now. Okay, I'll change it to Nokia now. So when I just try to print H over here, look at the output over here, what we get here. So we get it as Nokia, the same key is retained, but the value got modified here. So in simple terms over here, internally, okay, initially what will happen? One key and value pair will get created. This is key, this is value. Correct. This is what it would happen, no, internally. So one key and value pair will get created. Okay. So over here, the key is 1, the output is Sony value. 2 is key and the value is Apple here. So when I tell 1, it's Sony. 2, Apple. But later, when I tell H dot put off, one key and the value is Nokia here, when I try to have duplication key, the same key will be retained, but the value will get modified to Nokia here. But keys cannot be duplicated. But still you try to have a duplicate key, the values will get overridden. First it was Sony, now it will start pointing to Nokia. So that is what is happened here. One was Sony, but later when I try to have the same key, it will be pointing to Nokia here. So that's what we are supposed to understand. You can remove this two here. First it would be Sony, now it would be Nokia. This is all about the entire process here. Okay, done guys. Okay, so we're pretty much done with entire process with respect to collection here.